Welcome to Mimi's Math Channel. Today I am going to show you how to use pattern tiles to identify functions. In our class, we're going to focus on linear, quadratic, and exponential functions. So whenever I'm given a table or I'm given like the tiles, what I want to do, preferably with the table, is to look for the first differences of the y column, which in this case, for the first one, I have it notated as a function, f of x. And the reason it's f of x is because of the function name that's given. That still indicates that that's going to be my y values. So what I'm going to do is look for my y values to see how they're counting. And if there is a constant number the first time, that is considered linear. If the first time it's not constant, but if I go and I do it again and the second difference is constant, that is known as quadratic. If I see that there's a constant common ratio, which means I'm no longer adding, then that is exponential. So let's go ahead and work through some of these to identify the function and find a possible rule. Whenever your figures are given, that is going to be your input. That's x. So here we're just going to write 1, 2, 3, 4. So now in order to find your output, which is y, you would just count the blocks or the tiles that are underneath the figure number. For figure 1, I have 4 blocks. For figure 2, I have 6. I would keep counting and then I would write those numbers in the y column. Once you get your information in the table, you want to see how it's counting. So from 4 to 6, what did you have to do? From 6 to 8, what did you have to do? And then from 8 to 10, what did you have to do? Well, you had to add 2. Now don't forget, you also have to look at your x values and see how they counted, because they're not going to always count 1, 2, 3, 4. So let's go ahead and make a habit of that. What happened? I went from 1 to 2, which means I added 1. From 2 to 3, I added 1. And then from 3 to 4, I again added 1. So based off of the notes that I have above, I see that my first difference, well, we see now that that's linear, right? So we're going to go ahead and identify the function as linear. I gave you notes for how to find a linear equation, which is y equals mx plus b. We're finding the function, so we're going to replace this y with the f of x because that's the title that we put in our table. So that's what we're going to do when we write it. But in order to find your values, your m is your slope. Well, your slope is going to be your y divided by x, which is rise over run. Remember? So 2 divided by 1 is still 2. So we know that this m is going to be replaced with 2. And then in order to find our b is your y-intercept. We started with figure 1. We need to try to go back and figure out what figure 0 was. So you can do that two ways. You can go ahead and work backwards. So we'll start from 6. 6 minus 2 is 4. 4 minus 2 is, you guessed it, 2. And then on the other side, 2 minus 1 is 1. 1 minus 1 is 0. So what you should know is anytime you see a b, that's your y-intercept, and the y-intercept has to have an x value of 0. Visual representation kind of helps me a little bit more. So let's just say I'm looking at figure 1. I see that I have 4. What did this grow by when it went to figure 2? Well, it grew by 2. So I'm going to go ahead and cross out 2 of these. What did this grow by? It grew by 2. And you can do any 2. What did this grow by? This one also grew by 2. So I'm going to go ahead and cross out 2. So I noticed that I was crossing out 2 in every one. So let's go backwards and cross out 2 for figure 1. When I crossed out 2, what I initially would have started with in figure 0 would be what you currently see that's not crossed out, which would have been just 2 blocks. That's where this 2 is coming from. And then my rule for this, because it gave me the function name of f, I'm going to call it f of x. And I just said that your slope is going to be your y divided by your x. You have to put the plus b portion, which we just found out is also 2. And that is your possible rule for this linear function. If we went on to this one, we see that we still have figures 1, 2, 3, 4. So I know this time it's not called x, it's called s. And that's okay. It still represents your x on the x-axis for a graph, and h of s, h because that's the function's name. And whatever this is, that's what you're going to put inside of the parentheses. So this still represents my y column. What I'm going to do is I'm going to write the 1, 2, 3, 4, and then I'm just going to count the number of blocks that are under each figure, and that is going to be my output h of s. What did I have to do to go from 4 to 6, and then from 6 to 10, 10 to 16? Well, I can clearly see that that it's not going to be the same number. So that's not the first difference that is constant. So under the S side, I still see I'm counting by ones. These are not constants. So this was the first difference. Let's try the second difference and see what happens. I see that my second difference is actually constant. It's a constant of 2. So now for quadratics, it's a little bit more that you have to do when you're trying to write the rule. In order to find A, first off, just know that the standard form of a quadratic function, if you don't know this already, is f of x, if it's a function, or y, if it's an equation, is equal to ax squared plus bx plus c. In order to find a, I'm going to take 1/2 of the constant from the second difference. Well, this was the second difference. So if I take 1/2 of that, it's simply 1. So a is equal to 1. Then I'm going to look at c and recognize that c is going to be my y-intercept, which means where on the table is x0. So I'm going to have to work backwards again. I noticed that I was going from 6, I'm going back to my first difference. 16 minus 6 is 10. 10 minus 4 is 6. 6 minus 2 is 4. But it was counting by 2. So 4 minus 0 is going to give me 4. And you're saying, where are you getting 0 from? If I added 0 here, it's going to go 4 plus 0 is 4. 4 plus 2 is 6. 6 plus 4 is 10. So I was just working backwards to get to my y-intercept. So now I know that my c value is going to be a positive 4. B is the part where you're going to have to take some information from your table, and it doesn't matter which one that you use. So you're going to substitute any x value here, wherever you see an x, and then you're going to substitute in for your y value. Remember, your function name is your y. So f of x does represent my y. So I'm going to take any one of those coordinates and I'm going to substitute it in, and I'm going to solve for b. I think I want to use the one with 1. You always want to use a given. So you could have used 2 and 6, 3 and 10, 4 and 16. I'm just going to use 1 because that's just easier to multiply, right? If I'm looking at the coordinates 1 and 4, this is x, 1 is x, and 4 is y. I am trying to look at substitute into this formula. So the y is going to be f of x. So I'm going to replace that with 4. 4 is equal to a, we just said it's 1. So I really don't have to write that, but I am. Parentheses 1. Anytime you substitute, use parentheses. My x is also 1. And so that is squared based off of the formula. And then plus b, that's what we're trying to find. X is still 1 plus c, and we just said that c was 4. So now you just simplify this, and this is what it would look like. Okay, so we see that b is -1 after we finish doing our math over here. So since b is -1, we're just going to put the entire rule together in this form. So over here, the name of my function is h, and this is because a is 1, so it's understood there's a number here. B is -1, it's understood there's a -1 here, and then c is 4, positive 4. So if I just wanted to find a number like 40 under s, I would go to s and I would replace it with 40 each time I saw the s. Whatever this answer is, that would be my output, h of s. Now for this example, we see that the numbers are still 1 through 4. So we're going to do the same thing, but this time x is now replaced with n. So under the n columns, that's where we're going to put 1 through 4. And then the function name is g of n. So that's going to be my y column. I'm just going to count the tiles that go under the figures, and that's what's going to go under the g of n. So it'll look like this. I could try to find the first differences, and I could see clearly that it's not going to be linear because 2 plus 2 does give me 4, but 4 plus 2 does not give me 8. And then if I were to go to my second difference, it would not be a constant number. I want to ask myself, well, can I multiply something? Let's see. 2 times what will give me 4? 2. 4 times 2 will give me 8. Okay, I'm seeing a pattern. 8 times 2 will give me 16. And then on the other side, it's just simply counting by ones. So my rule above told me that if I had a constant common ratio, and this is a ratio when I'm multiplying like this, if it's constant and it's common, that means that it's an exponential function. So in order to find your exponential equation, y is equal to a times b raised to the x power. So a is going to represents your y-intercept at this point. So that's where your x value is equal to 0. So you're going to have to go back and figure out your 0. And your b is the common ratio, where it's the base, or it's like either growing or decaying. What's happening here is it's growing. So 2 is going to be my b. All right, so I went ahead and filled in my y-intercept. So I see that my a would be 1. There's really no need to write 1 times 2 to the n power. And the reason the b is 2 is because that's my common ratio. Now, how did I get this 1? Again, I worked backwards. So instead of multiplying forward, I just went backwards. I did the inverse. So 4 divided by 2 is 2. 2 divided by 2 is 1. You're just either going forward or backwards. The next two are just examples of where it can be linear or exponential. However, it may not look the same as what you're used to. I want to pay attention to the first column all the time. I don't want to assume it's always counting by ones. In this case, it's not. So let's go ahead and see what's happening with our y values. All right, so let's see what's going on with the x column. So what you'll notice is in the x column, you are still counting by ones, like 3, 4, 5, but not literally like 1, 1, 1. So what you're going to have to do is take your slope, which is y divided by x. When I do that, I'm going to see that 6 divided by 3 is equal to 2. And then we have 8 divided by 4, which is also equal to 2, and 10 divided by 5, which is also equal to 2. So this was my first difference. So it's still a linear equation. I want to go ahead and find a rule. And my rule again is y is equal to mx plus b. And I know what my m is. We just said it's 2. But how do I find my b? I have to work backwards. I see that I'm going from 6 to 8 to 10. In front of this 6, like 6, 8, 10, I should probably have a 4. I could say 7 minus 4 is going to give me 3. Let's just see if this is right. Mathematically, however, I could use this formula and I could solve for b. Remember, b is my y-intercept. And that's just saying that I can choose any x or y coordinate from this table. I'm going to always go for the smaller numbers. And then substitute it in and solve for b. Once we solve for b, this is what it looks like. b does actually equal 3. When does b equal 3? When x is 0, because your y-intercept means that that has to be the case. Let's go ahead and put that b here, which is going to be 3. And this is my rule. And when I say my rule, I mean something like, what would it be if x were 20? And I wanted to find what the output would be. I would just substitute it over here. So it says y is 2 times 20 plus 3. So once I multiply that out, 2 times 20 is 40, and then 40 plus 3 is 43. So y is 43. If I wanted to write it as a coordinate, I would say when x is 20, y is 43. It all ties back to your graph. And once you're graphing it, it would be a line. The last part of this video is, let's say you had a table that looked like this. This is an exponential function that has a value for a. The other one had a value for a, but it was 1. When I look at these numbers, I see that they are growing exponentially. So that's a telltale sign that I'm not going to even try to add. What's happening here is I am growing by taking 6 and multiplying it by 3, taking 18, multiplying that by 3 to get 54, and then I take that 54 and multiply it by 3. So that's going to be my common ratio. All right, so now that I know my common ratio, I need to know what the actual parent function of an exponential function looks like. It's going to look like f of x is equal to a times b raised to the x, where a, we said, is going to be our y-intercept. So we need to go back and try to figure out what our y-intercept is. That is when x is 0. Well, we have a pattern here already. So if we're working backwards, 54 divided by 3 is 18. 18 divided by 3 is 6. 6 divided by 3 is 2. So this is my y-intercept, and that's going to take the place of a. F of x is equal to 2 times, what common ratio did I have? 3. So that's going to be my b. That is my rule. So those are the different ways that you can use tiles and tables to figure out how to identify your functions. I hope this helped. Please remember to like and subscribe. Have an amazing day.